part D, find the total distance the particle travels from time t equals 0 to time t equals 3. And this is going to be extremely easy with the calculator. Before I do the calculator, if you remember from I think it was part B where I happened to graph it, the graph of velocity ended up, it's done this a little bit, looking something like this. And if I integrate velocity, I get displacement. Displacement and total distance are not the same. Displacement is going to add on this positive area and subtract off the negative area. And that is how displacement works. For distance traveled, I want to add this area and add up, accumulate all the areas. We don't take anything away, everything's sort of positive. So it's going to end up being that the distance will equal the integral from 0 to 3 of the absolute value of v of t dt. Now I could, if I wanted to, split it into two integrals and find the integral from here to here, and then change the sign of this and find the integral from here to here and add it up. If I did not have a calculator, that would be the way I would do it. But since I have a calculator, I'll just type this in. The calculator will take longer because of the absolute value, but not that long. So here we go. Integral, and we want the absolute value. Again, if you have one of the newer calculators, the newer operating systems, you can pretty much type this in and you'll get the answer. But I'm going to just do it on this old one because if you would have trouble with this, you probably wouldn't have trouble with the new operating system. 2 sine x squared over 2. Close off the absolute values with respect to x from 0 to 3. And you see it's taking a little bit longer than we might expect. Usually that absolute value does mess up the calculation. It makes it do more work. And we'll see it gives us that this distance traveled is approximately 5.301.